My name is Subeh Chowdhury. I'm one of the lecturers here in transportation, civil engineering. Can I see a show of hands of the parents here who are civil engineers? Oh, no one. That's quite surprising. So the way that I came into civil engineering was I came to Ingenuity Day, which is a day for women in transportation. So I came from school. My dad is a civil engineer, so I had some influence from that growing up. Once I did my bachelor's, I then did 3 years in the industry. After completing while working in the industry, I decided that I wanted to pursue my degree a little bit further. I wanted to learn a little bit more. So I came and I did my PhD here at the University of Auckland, and then I joined as a lecturer. So, hence the title, I am a civil engineer. When it comes to civil engineering, I think a lot of people think about civil engineering as one aspect. So there are actually two types of things that civil engineers mostly do. They design to build. So when we think about engineering, we think about engineers as being builders. So they design to build things. But a lot of now engineers are actually working a lot with people. So there are some engineers that work with both. So they design things as well as work with people. So as civil engineers, we care about how people live and how people move. So a lot of civil engineering, if you look at the discipline itself, the core of it, we actually look into improving the way people live, so their well-being, as well as how people can move from A to B in the most efficient way. So here are almost some examples of what a civil engineer does. So we build roads, we build rail lines, bridges, monuments, airports, high-rise buildings, houses that you live in. So these are just some of the things that engineers actually do when they are building. So they're designing all these things to be built. Going forward, for the civil engineering profession, I would say that these are the top 3 sort of issues that needs to be addressed. So a lot of people are moving into cities. So cities are becoming larger. More people are also coming into cities. So that means each of the cities are becoming more dense. So as the density increases, there is a lot of pressure on the infrastructure of cities. Then autonomous vehicles are not a myth anymore. They are going to, it's not just an idea, it's not just a concept. I think autonomous vehicles will be integrated into the society. So autonomous vehicles are driverless cars, which means that you won't have to drive on your way to work anymore. The way that we move around could significantly change once driverless vehicles come into play. So that is a challenge for transportation engineers like myself. We have to try and understand how people can move from A to B using driverless vehicles. What are their needs? How do we actually design the infrastructure so it meets people's needs? Smart cities, so everyone now has a smartphone. I remember when I was in high school, I had those Nokia phones that you could throw against the wall and it won't break. Texting cost 20 cents. So it was very expensive. And now you can text as many. Sometimes look at my phone, it's like 100 texts. I'm like, wow, that's a lot of text to go through. So the way that smartphones has changed the way our relationship with technology also has an impact on what we expect from the infrastructure. So just as we expect things from technology, we expect similar results from the infrastructure. So we want to be able to engage with the infrastructure the way that we do with technology. So, for example, Uber, Lyft, all these sort of services with transport, they only came about once smartphones came into society. Once everyone started using smartphones, that was only when Uber and Lyft existed. So these new ventures, these new companies, these new services arise once technology is integrated into society. So first challenge, when we have more people in a city, what do we need? We need more movement of people that are pedestrians. So in transport, we have a term for these. They're called vulnerable road users. The reason is because when you are a vulnerable road user, you do not have the protection that, for example, a car offers. So because of that, with more pedestrians and cyclists on the road, given more people, that means that the streets are getting busier. There's more probabilities for accidents to occur. Then you need more housing. Where are all these people going to live? When you have more housing, of course, there's going to be more waste. So where's all the sewage going to go? You need more drinking water. There's going to be more cars on the road. So the pressure on the infrastructure dramatically increases as you have more people coming into the city. So here's an example of a busy city. Auckland doesn't look like this just yet. But there are many cities, I'm sure you can think examples of, where it does look like this, where the air pollution is really dense, it's bad, and you can actually feel it in terms of its quality. And then you come to New Zealand, you're like, I'm able to breathe again, you know? You have more people, as I was saying, more people as pedestrians walking on the road. So that means that there's going to be extra pressure on the transport network. And what we're doing is we're actually moving away from cities that look more like this. So we actually have cobblestone pavements which encourages people to walk instead of getting into a car. So there's encouragement to, you actually want to walk down the street. There's some greenery, and you've got the pavement. It kind of invites you to actually walk. So the other issue with busy cities is that lots of people they become so time poor. So that's another term. It means that they're so busy that they don't have enough time to actually do active mode, which is walking and cycling. So what happens then is that in some cities, people, the health of people actually deteriorate because of that. With more cars, there's more congestion, so there's more fumes in the air. So therefore, a lot of cities are now putting in sort of green patches in their city area so that people can walk and the air is cleaner for them as well. So this photo was a photograph that I found online, and it was from the Netherlands. So places, a lot of like sort of Dutch cities are actually sort of, they've actually understood this long before, and they have created these cities to make it more livable. So with busier cities, we are actually becoming more like this if we don't, as transportation engineers, think about the impact of the infrastructure on how people live. So that was infrastructure, working with people too. So that's another aspect of civil engineering. You get to engage a lot with the community. So for example, there is a lot of push for sustainable transport, public transport, walking, cycling. And then the other thing is there's a lot of natural disasters that's occurring. So the occurrence of natural disasters has actually increased in the last decade or so. And because of that, a lot of communities are now building back to be more resilient. So this falls under the area of disaster management, which is one of the aspects of civil engineering that we teach at the university. For example, my work involves travel behavior. So I look into how people want to travel. So if you want to go from A to B, what is your mode choice? What are your needs from the transport infrastructure? So that's my area. So I look into sort of the infrastructure, and I look at its impact on people. I have other colleagues who look into disaster management. So when a cyclone hits, or when you have an earthquake and people can't move and reach facilities like healthcare or like just even the grocery shops, or everything, their house is completely ruined and they have to go live somewhere else. So I have colleagues who look into resilience of communities, and one of my friends looks into building back better. So that's looking into how communities can actually rebuild their communities such that when a disaster hits the next time, they're not impacted as negatively as they were when they were not designed properly. So what can we as in civil engineering actually offer you? So civil engineering is actually broken up into these 6 categories. So there's transportation, structures, geotechnical, environmental engineering, hydraulics, and construction management. So transportation involves designs of pavement. So the black surface that the car goes on, we design we design between either making it asphalt or chip seal. So we look into designs of roadways in urban area as well as in rural area as well. We look into places where there might be more pedestrian movement versus where there's places that needs to be accessed by car. So that's pavement design. Then we have designing for signals. So this is when you have that green light and then you go to that next signal and then it's green again and you're like, oh, I'm on, today's my good day. I keep going, getting all these green lights. It's the phasing and it's the design of it that is, there's someone behind it that actually has designed different phases. And if you get stuck into the amber, so the yellow phase, then the next one you go to, you reach amber again. So that's just the design of the cycles. So there are people that actually design the phases so that we control for the movement and we give priority to the movement that has the highest volume. So if you look at an intersection and there could be certain routes that get, like the certain lanes that get 3 to 2 minutes, and then there are others that only get like half a second, and you're like, why is my movement so short and they get a longer green time? The reason is because that movement may be the dominant movement for that intersection. So in order to clear the path so that there isn't any bottleneck occurring, so there isn't any congestion occurring, we need to allow that longer green phase. So there are reasons for why certain things happen. Then in terms of signals, we then think about, well, do we want to actually put a signalized intersection here, or a roundabout, or a stopway, or a give-way? So all of these have some sort of logic behind them in order to design an intersection and find the best design for it. Public transport, so this is my field. We look into sort of things about how the transport system operates. So in Auckland, there has been a lot of improvement with the public transport system, but there still could be more improvement happening. So with public transport, it looks at the operation, the policy, what people desire from it, and what operators can actually offer. So it looks at all the different segments in the actual design of public transport systems. Cycling and walking, they're known as active modes, and there is a real push from Auckland Transport to try and increase this. A lot of us in Auckland are extremely dependent on our cars, so as a result, we don't actually get out and move around as much as we should. So there is that need to get people moving about the city more. And that has to relate with the type of city that you also offer. So the different types of land uses, the connections between different destinations and your house. So if you want to go from one place to the other, which mode would you use? That depends on how efficient each of the modes are. Evacuation modeling. So this is looking at, for example, if there was a volcanic eruption in Auckland. Say it happens. So volcanic eruption, I think the last one happened 700 years ago. So there is some talk about it happening, maybe not in the near future, hopefully. But if it does occur, then how do we actually get all the people that are in the city center around this area to get them out away from the city center? So that's mass evacuation. That's a lot of people leaving the city center, and that means that there's a lot of pressure on the roadway as well. So these are the main topics, but within these topics there are also lots of subtopics as well. So I just wanted to give you an overview of the main topics. Structures, so buildings and bridges. My brother is a bridge engineer, so he did his bachelor's here and he specialized in structural engineering, and he really enjoys it. So one of the things with our degree is that you could learn here and then you could go anywhere else in the world. So after he completed his bachelor's, wanted to do master's over in San Diego. So he went to the University of California, San Diego, UCSD, and he did his master's there. Then he came back. Then he decided that he wanted to go work in Australia. He went and worked in Australia, in Sydney. Then he's like, okay, I actually want to go to the UK. So he went to the UK and did another year there. And then after a year there, he's like, all right, I think I'm back. I'm okay to come back to Auckland. So now he's working here. So I was quite amazed at how easily he was able to transfer his skills from one place to the other. And that, again, is a reflection of the degree that we offer here. So structures include designs of concrete, so concrete buildings, timber houses. We look at steel. So steel is usually used to reinforce the concrete. Concrete is a very brittle material. So although it is good for strength, it's not so good when it comes to looking at forces that actually creates movement. So therefore, steel is actually used to reinforce the concrete so that it gives it the two properties that it requires. So it's not so brittle. There's timber, steel, designing for seismic forces. So the Christchurch earthquake, I think, was a big wake-up call for New Zealand, looking into the way that our buildings are actually designed. So a lot of now buildings that are being created are actually being designed for earthquake forces. There's designing for wind loads, as well as the various types of bridges, so cable stay, steel trusses. So when you go through a steel bridge and you see all the members, so that's a steel truss bridge. And each of this is dependent on, do I have geotechnical? Yes. So each of this, the design of different structures is actually dependent on the ground and what sort of soil you have. So geotechnical engineers look at the stability of the ground. So they try and create a good foundation for the infrastructure, for the building. So the Leaning Tower of Pisa is a good example of what happens when you don't have a good stable foundation. And we don't want our buildings around the city looking like that. So geotechnical engineers are very important. So they create the foundation for buildings, piles for bridges, retaining walls, so that you don't have landslides. So we have one of our doctoral students who's looking into landslides victims in Bangladesh. And that's a major issue there, because a lot of times when landslides occur, they're another sort of almost like a natural disaster. They ruin a lot of communities, they ruin a lot of households. So there's the retaining walls actually help maintain that. I call environmental engineers the green folks. But that's just a term that I use because it helps me think about their specialization. So environmental engineers look into the water, the quality of the water that you drink. So at Course and Careers Day, when I came in, my colleagues saw my bottle of water and they said, "Is that water good for you?" And I'm like, "Yeah, I got it from home. I'm sure it's fine." They're like, "Well, why don't we test it and let you know?" So they made me pour a little bit of my water into their sample, and they're going to do some tests on it and let me know in 24 hours if the water that I'm drinking is safe. And I'm like, okay. I'm hoping for good results. So they look at drinking water, wastewater. So when you actually flush the toilet, it disappears. They make sure that it actually doesn't just go onto the water bodies. It just doesn't get released into rivers and the sea. That you actually treat it before anything goes out into the water body. Stormwater is all the rainfall that occurs. So when you have a heavy rainfall occurring, then when you have impermeable surfaces, so concrete, then the water is not able to seep through. So then what happens is you get all these runoffs. So from these pavements, from these concrete surfaces, the water runs off and they have to go somewhere. So that's why you've got drainages. You look at how to actually make sure that the quality of the rainwater, again, is all right before it gets released into the sea. So here's an interesting stats for you. By 2025, 50% of the world's population will be without adequate sanitation. That's quite a lot of people. And one of the things that environmental engineers look into is developing countries. So there's a whole area in developing countries, and the issue around drinking water, sanitization, just basic livable conditions. So when people think about the basic human rights of living, one of them is getting access to good drinking water. That's one of the main things that people usually think about when they think about basic needs. So good shelter, good transport facilities, drinking water, good sanitation. A lot of our environmental engineers go into what's called Engineers Without Borders. So this is an organization, a nonprofit organization that goes to places that are in need, so places in developing countries, and they help design certain infrastructures for them so that communities can get access to the basic needs. So I've got a couple of friends who are in Engineers Without Borders, and that's sort of I get a lot of stories from them, and it's quite interesting because when you actually do something, when you actually go to a remote place, you don't have all the facilities of first world country. So you don't get all the comfort of it. And then when all the comfort is actually stripped away, you actually see the basics, what of human need is. And you get to design for it. And whatever you design for, the impact is almost 100% because it's directly for the end user. It's directly for the people in the community. So it's very rewarding, and it's a very rewarding job. Hydraulics engineering, so they look into sort of larger water bodies. So there's dams, movement of large water bodies. So like, for example, a tsunami, when a tsunami hits, pipelines and sediment movement. So when large bodies of water move, they also move because of the seabed. They also move sediments with it as well. So there's some studies to look into how that movement is, because you don't want all that sediment to come and be stored in one place. You want it to actually look at the type of contaminants that's being carried with that sediment as well. So hydraulics engineering is quite interesting. We have a really good lab here. The lecturers we have for this are world class. They're really well known globally. So it's a good team. So engineering at the University of Auckland. By 2020 or 2021, we're expecting to have the new building, so it's already in progress. This new building will have new lecture theaters, places for students to learn. As I mentioned, our lecturers are actually world class, so a lot of the research that we do in this faculty is known globally, and a lot of our lectures are very well recognized, and I think it's quite a, when you go overseas and you think about New Zealand and it's like a small city, a small country, and you think of Auckland and it's even a smaller city, and then you go there and you hear about your colleagues, it actually makes you feel quite good, and it makes you feel quite good, especially as a graduate from this university. So we have a number of new labs. So this is the structures lab, that's the test hall. Geomechanics lab, so lots of testing of the soil is taking place here. Hydraulics lab, so that's the sediment movement test fume, and then there's the water movement one. So one of my colleagues looks into the movement of water and how it perhaps different infrastructures are resilient to it. And this is the transport lab, so this is where we look into a lot of the pavement and the design of it, and we have a lot of students that actually do hands-on work, and there's a lot of lab components when it comes to civil engineering studies. We make sure your hands get dirty, but not too dirty. Environmental lab, so environmental engineers work a lot with chemicals and a lot with microbiology and chemistry. So if you really like chemistry and you're indecisive about should I do chemistry or engineering, so environmental engineering could be for you, because a lot of what they do has to do a lot with chemistry. So these are new areas, MDLS, so they stand for multidisciplinary learning space. So all these tables, we can move them around. We've got screens all around the the area. And the idea of these spaces is to allow the interaction between the lecturer and the student, that gap, to be reduced. So a lot of times in the lecture theater, it's very much like this, where you've got one person standing and everyone else sitting and listening. And it's very difficult for lecturers to actually engage with the students in a setup like this. So these spaces allow for us to have smaller groups and to actually interact with the students and see where the progress is. And if there are perhaps a certain bit in the curriculum that the students are finding difficult and they're finding it difficult as a class, then the MDLS gives us a space for the lecturer to actually interact with the students to try and improve that learning. We also have a Civil Engineering Student Body Association. So this is CISA. They have a Facebook page if you'd like to check them out. They do all sorts of fun activities. So they're run by students for the students. They invite guest lecturers from the industry to give the students an understanding of what kind of work that civil engineers do. So recent graduates to people who've got 10 years experience, 15 years, so forth. They do a lot of social activities. So this is a cocktail dinner thing they had a couple of months ago. They also do team building activities. So over here, the students are building the tallest tower, and the tallest tower gets some kind of prize. So it's a really good team of students. It's run by students, so they've got a president, a secretary, and lots of other roles that students can get involved in. And yeah, it's quite exciting. So in the final few minutes, I'd just like to emphasize that I know it's a big decision. If you're year 13 and you're thinking about going to the university and you're thinking, well, this is it, I'm going to decide my life and I will be this person forever. One of the things that I want to sort of explain to you is that with an engineering degree, so not just civil, any other engineering degree, it's not the end of the road. If you really like it, then that's great. But if you find yourself that halfway through the degree that engineering is not for you, it's also okay, because with engineering and the skills that you develop as an engineer, you can actually use that in other professions. So a lot of my friends actually do other things as well. A good portion of my friends, by the end of the civil engineering degree, decided that they didn't want to be civil engineers. But they took the skills that we learned in class, they took the problem-solving skills, the management skills, the social skills that we learned in class, and they applied it to areas that they were passionate about. So some people got into their hobbies, and they used their engineering degrees to fulfill that dream. So if you have any questions, feel free to ask us. We're here all day at the Careers and Careers Day down in level 3, and I hope you enjoy the rest of your day.